Hi everyone, today I want to introduce you a circuit which will be used as a building block for our next video. Let's take a look at a simple RC charging circuit. This circuit is commonly used when you require a timing component for oscillators or 555 timers. The working principle of the circuit relies upon different sizes of capacitors will require different amount of time to charge and discharge. To check this on an oscilloscope, we'll create a simple circuit which will have a voltage source Vs, a switch S1, which will allow this capacitor to charge through R1. We will also create a discharging path for this capacitor via resistance R2 and switch S2. At a time, we will either activate S1 or S2 so that we can clearly monitor the progress on oscilloscope. The mathematical formula for RC charging circuit is time t required in seconds is equal to resistance R in ohms multiplied by capacitance C in farads. One time constant is equal to time required for capacitor to reach 63% of applied voltage. To fully charge a capacitor, usually more than 5t time is required. We will use a variety of resistors and capacitors to check how it affects the time required to charge and discharge. Let's go to the breadboard and see this circuit in action. Here I have assembled the circuit on a breadboard. We are using a 5V supply, switch S1, the resistance R1 which is currently 219 ohms, a capacitor which is currently 47 microfarad, switch S2, and a discharging resistance which is approximately 5K for now. Let's go to the oscilloscope and see how it works in action. To see the circuit in action, we have put our oscilloscope in single shot trigger mode and the triggering voltage is much closer to the supplied voltage. You can see it here. I am triggering on 4.78 volt when the supplied voltage is 5 volt. Let's press S1 now. There you go. This is the capacitor charging curve. Earlier the capacitor voltage was 0 and then as soon as we pressed the S1 the charging started to happen. Let's see if we can measure this using some cursors. I have already configured the cursors. The Y2 is at 0 volt, Y1 is at 3.16 which is 63% of applied voltage 5 volt, and these X1 and X2 when I started charging and the time required for it to reach 63.2 volt. Oscilloscope tells me that it took 10 milliseconds to reach there. Let's see if the calculator agrees. We are using a 219 ohm resistance multiplied by 47 microfarad capacitance, and we should require 10.29 milliseconds, which is closely matching to the figure. Now let's see if we change the capacitor from 47 microfarad to 100 microfarad and do not change the resistance R1, if there is any change in the time required to charge. I have replaced the capacitor on the breadboard, put my oscilloscope into the single shot trigger mode, and let's see what happens now. This is the curve for 100 microfarad capacitor to charge. As the cursors are indicating that the time required is now 21 milliseconds. And then I did the calculation and it should require 21.9 milliseconds, which is closely matching to the results which we are expecting. Now let's see, by changing resistance, is there any difference? I just changed the capacitor to 47 microfarad and put a resistance of 1961 ohms. Let's see if it changes anything. Now let's try to put our cursors back in. That sounds about right. And as per calculation, it should be around 92.1 milliseconds, which is looking pretty close now. I will not go through all the resistor and capacitor combinations, but I hope you understand now that you can change the time required for capacitor to charge can be controlled easily via different resistor and capacitance combinations. In the coming videos, we will use this concept to make some fun circuits. I hope you enjoyed. Give me a thumbs up if you liked the video and subscribe to channel to see more videos from me.